Find the volume that would be created by revolving the cross-sectional area shown around the line x equals 10. So an important line in this problem is going to be this vertical line x equals 10. It's going to be what would be referred to as an axis of revolution. And what I want to do is just draw the shape that would be created in this situation. So we're basically going to take this cross section and make a sort of donut shape by revolving it around. And this is just half of the donut here, because really it would look like this. That's the shape we want to make. I'm going to use the shell method to do this. And for that, I just have to pick an arbitrary point to draw a typical cross section. And it'll look like this. Inside the shape, it's just a hollow cylinder. That would look like that. All right, so one thing we're going to need here is we're going to need the height of the cylinder. And you could call it h of x or f of x. In this case, it's a height of 4. The height of each cylinder is 4. Now, each cylinder also has a thickness, dx, and it's going to match on the other side too. At this point, we need an expression for the volume of that shell. I showed in a previous video that we could get the volume by multiplying circumference times the height times dx. Now the circumference is the distance all the way around. And there's also going to be a radius of the shell, which I'll call r. Now both c and r will depend on x. They're going to be functions of x. But how do we calculate the radius? We need the physical distance between the edge of the shell and the axis of revolution. Okay, so now we need a formula that'll give us the radius, which is the distance from the axis of revolution to the shell's outer edge. The formula that I'll use here will be r of x equals x minus k, and I'll take the absolute value of that because I want the radius to just be a positive value. if our shell's edge is at a point X, and the total distance from the y-axis to the axis of revolution is k, then it should make sense that if we just subtract them two, get the difference of them, then we'll be able to find the radius that we need in our formula. So let's plug in our numbers. Our k is 10. And let's recall the formula for circumference. That's going to be c of x equals 2 pi r of x. So we're going to get c equals 2 pi x minus 10. All right, I'm just about ready to plug in to my dV formula. Circumference is a function of x. H is a function of x. And we have everything we need. I'll integrate both sides. And I'll make my limits from 0 to 8. Since my x values are always going to be smaller than 10, an easy way to rewrite this would be two pi times 10 minus x times 4 dx. That way I don't have to deal with the absolute value. All right, this is going to give us 80 pi minus 8 pi x dx. Take the antiderivative. And we get 384 pi. All right, now how could we check a result like this fairly easily? We could use geometry formulas and a simple subtraction. The reason why a subtraction would work is if we could calculate the volume of a big cylinder and then subtract out the middle, then that would leave us with the volume we need. So how would this work? Well, we need to do V equals pi r squared h for the top piece. and this would be a radius of 10. That's going to give us 400 pi. Then we want to do the same thing for the little piece, which according to the picture, it would have a radius of 2. So we're going to be subtracting out 16 pi. And let's just take this and subtract this. And it checks.